All right, so 20, excuse me. Number 20, guys, number 20, you have a first quadrant problem. Okay. So we start with the first quadrant. We know that because the x and y are greater than or equal to 0. So we know we have first quadrant. That next line, it says that negative x plus y is greater than or equal to 0, which basically means y equals x. All right. So just by graphing that through, I know that I would just do this. But I have to figure out what side to shade. So pick anything that's not on there. Like, I don't know, 10 and 0. Just making up a point. Is negative 10 plus 0 bigger than 0? No. So it's false below, true above. Are we okay with that? Next one, you're set up for quick graphs. You have x and y intercepts. You have a 2 and a 4. Bless you. Did it go through the origin? No. So what's 0 plus 0? 0. Is 0 bigger than 4? No. So it's moving outward. I did run into this here, though. Okay. So what I want to do, real quick before I go on, is figure out that intersection. That intersection point is pretty easy, bless you, because we know that this line here is at y equals x. So what I'm going to do is just substitute that in here. And I'm going to get 3x is y. I'm sorry, 3x is 4, so therefore x would be 4/3. Okay with that? So then if x is 4/3, what would y have to be? 1/3, because of this again. All right. Do the next one with the quick graphs. You have an x-intercept of 13/2, otherwise known as 6.5, and y of 13. And 0 plus 0, that one's moving inward. So here we have a region here, but I have to figure out this point. Well, again, knowing that you have y equals x, 3x is 13, therefore x is 13/3, which makes y 13/3. We okay with that? The only thing that stinks about this one is that you have to worry about some nastier fractions. If your objective then is to figure out the maximum and minimum value in that shaded region, all we have to do is take those 4 ordered pairs. The 4 ordered pairs that I would be working with will be 0, 13, 0, 4, 4/3, 4/3, and 13/3, 13/3. And I just check all 4 of those. Okay. I'm going to guess you get minimum at 4/3, 4/3. Just taking a guess. And then maximum, you probably. Is it 13 thirds? I'm just guessing. So, does that help on that one? It's just weird with the fraction of that. Right. It's most people freak out when they see that. Other than that one, anything else all right? So, let's have some fun. Define fun. We're going to put the fun in functions. Most people say typically, well, I'll keep it clean for early in the morning. Don't write this down. What I've done here is I've taken the liberty of printing out the first couple of word problems that we look at. So that way you guys get the idea of what to look for. Excuse me. So, don't. Seriously, you're going to be fine. Believe me. These look sound terrible, but as you get into it, no, they don't. No, they don't. As you get into them, what's going on with these things is very, very easy to take what you need out of the information. For example, you are planning a fundraiser, just like you guys always plan fundraisers. And you come up and ask me, "Are you buying something?" I say, "No, I don't want to buy anything. I don't buy my own kids' stuff. I buy kids' stuff." Come on up, Nate. Sure.
Why do you guys go fundraising for man, what a great
Well, we don't like we don't need to really raise funds.
Pay for it. Just pay for it. Like, just ask for money.
Now, one thing I will tell you, we are going to be buying some extra stuff from the math team this year, and we'll have spares. The arm sleeves. So if you want to buy one, we'll have extras.
Why would I want to buy one?
Why
Wow,
would you?
you're so much better.
We Wednesday of Wednesday for school. So, yeah, for those of you guys wondering, the first math team meeting, we're gonna have a brief thing on Wednesday morning in here. Just kind of explaining what the plan is going forward. Seven and I didn't want to do anything after school this week because of homecoming. We knew this was a nightmare to get things together. So we just figured a quick little 10 minutes to talk about what's going to happen, and then next week we'll start up with the pre-testing stuff. Anyway, linear programming. Linear programming is what we're doing. We are creating shaded region areas via constraints. But as of right now, the past day and a half or so, you guys have been given your constraints. And what we need to do today is develop our own. What we have to do is develop our own constraints to identify what your objective is within a problem. So a lot of times when you're reading these things through, the easiest thing to figure out is, what's your objective? Well, let's take a read. Your club is planning to raise money by selling 2 sizes of fruit baskets. The plan is to buy small baskets for 10 and sell them for 16, and large for 15 and sell them for 25. The club president estimates you will not sell more than 100 baskets. Your club can afford to spend up to $1,200 to buy the baskets. Find the number of small and large fruit baskets you should buy in order to maximize profit. What's your goal? Maximizing profit. Okay. Your goal is to maximize profit. All right? Think of that as your objective function. Remember how all the other ones we were doing with the constraints, you had that C equals something or another, you find the maximum and minimum. Well, that's what that means. You want to maximize profit. Okay? So where in this problem does it discuss profit? All right, let me ask you this real quick. What does profit mean via when you're buying and selling stuff? Correct. When you sell it for more than what you buy it for, that is profit. So in the problem, there are 2 pieces of profit. You have profit. You have a profit for a small basket and profit for a large basket. What's the profit on a small basket? $6. We okay with that? You buy it for, hey, what's up? You buy it for 10, you sell it for 16, your profit is $6. What's the profit for the large? 10. So your profit is 6 for the small plus 10 for the large. Now, this is the time where you're going to kind of label your own instead of with X's and Y's. You can put it together in terms of what you're selling or what you're buying or things like that. Here we have small, large, so we use S now. Okay with that? Now, here's another little thing. They talked about 2 constraints. They talked about restriction on the number of things that you might sell and the amount of money that you have. Everybody see that? The amount of money you have and the number of things you might sell. So if I'm looking at it, the first thing it says, they estimate you will not sell more than 100 baskets. So that's the maximum number you can sell. That's what the estimate is. So if you're going to sell up to 100, can you sell 100? Can you sell more than 100? So is it going to be a less than or equal to or greater than? What are you selling? What sizes? Small and large. So small plus large can't be more than 100. See how that works? It's not saying that you're going to sell 3 smaller for every 1 large or anything like that. It's saying your estimate is to sell no more than 100. So far, so good. Next bit is about money. How much money do you have to spend? Can you spend more than that? So it has to be up to and including 1,200. Well, how much is each small basket? What are you paying for? 10. And how much is each large? 10 for the small, plus 15 for the large. Oh yeah, sorry. Can you sell negative baskets? First quadrant problem. Yes. And I'll show you why. Okay. The reason we want to graph that is because we're going to look for that shaded region about the boundaries of where things can occur. So what you've done there is just by going through that word problem, just by reading what the objective is, maximize profits. And then you figure out where the profits come from. You sell or you buy. And then you start looking at, well, what are your constraints? You can't sell more than 100, and you only have $1,200 to spend. And you just go back and look for the information in the problem. So here then, we have our first quadrant problem. Excuse me. So, first quadrant problem. It does not tell you which is the S and which is the L. It doesn't matter how you label your axes. It doesn't, just as long as you're consistent with your points. So I would just say that this side is my small, this side is my large. It doesn't matter. Okay? Because you're not writing it out in terms of X's and Y's, we're writing out in terms of small baskets, large baskets. You okay with that? So from here then, it's a matter of quick graphs. That's the reason why I was showing you guys how to do that all the time. What are your intercepts for the small and large? 100, very good. All right, there's your 100. Inward or outward for the shade? Inward, yes, you're right, you're right. Is this making sense, the reason why I was telling you guys about just drawing the little arrows now? There's a method behind that. This is my brain. As much as it's hard to believe, there is reasons why I do things. Okay? There are reasons, excuse me. Me failed English. Next one, I have intercepts at 120 and another number, very good, 80. 120 and 80. And again, I'm moving inward. And the reason why I know that I'm moving inward is because 0 plus 0 is less than 100, at least on Mondays and Tuesdays. Okay. So, how do I find that point at which those two intersected? You don't? Well, you should. Yeah. Well, you can do a couple things here. Remember, we're treating it like we have before in terms of solving the system equations. You can multiply it by 10 and subtract, or I can just say that small baskets equal 100 minus a large basket. A lot of times when I have variables that have coefficients of 1, I usually use just straight substitution. It's just how I've always done it. If you want to multiply it by 10 and subtract it out, you're going to get the same result. It doesn't matter. In doing this, I can say then that 10 times 100 minus L plus 15L is 100. And then what's S then? 60. Okay. Now here's the thing, that ordered pair you got to be careful with. Is it going to be 40-60 or 60-40 for the ordered pair? It'll be 40-60. You all right with that? Because how I've labeled my axes, bless you. I've labeled my axes. I have my L value on my X term. So that means it's got to go first. Okay. That's about the biggest mistake a lot of times you get with these things. Not the substitution, you usually flip flop. So we have 40, 60. Which means that I have 1, 2, 3, 4 points then to substitute into my objective function. Just like you did over the past couple of days and a half or so. Once you start graphing these out, you get to the point of knowing where those things occur. But now it's just you are building up those problems yourself, as opposed to saying, hey, graph it. Or I'm sorry, here's all the stuff. Now you got to figure it out. Okay. So if I do that, we had our objective function, we'll move this up here, was what, 6 for the small plus 10 for the large, I believe. And I just have to use 0, 100, 40, 60, 80, 0, and 0, 0. Which of those you know that you're not going to be able to do? 0, 0, because your objective here is to make some money. If you don't sell anything, you don't buy anything, you're not going to be making any money. So there's that. So you can kind of say, hey, I don't have to do this one. Excuse me. Now, real fast, I just noticed this. Notice how I have mine labeled as L and S?
No.
See how S and L is flip-flop? Be careful. Be careful when you substitute in. Remember what goes where. Yeah, L, in this case, when I label these through, it'll be 6 times 100 plus 0. 6 times small is 60 plus 10 times my 40, or 6 times what? 0 plus 10 80. Well, this is 600. We do that one. This is 800. And the middle one is 760. You didn't do it wrong. I just went with the one easy I can in my head. So, what should you buy in order to sell? Just buy 80 big baskets. Sell 80 big baskets. Walk around saying, fruit for sale! Yep. Limit your options. It's like with restaurants. A lot of restaurants have too many options. Most airplanes don't even get an option anymore. Yes, that's that. All right. Was that scary, horrible, terrible, bad? Oh, shut up. You don't care. I should have known that was going to be a response. I should have. That's why. All right. Yes, ma'am. What do you mean? Because the question is how many should you? Well, if you just say 80, you don't know what it is. You know what I mean? You should probably tell me which one it is. But here's the deal: when we get into this, I know what it is. So does that make sense? That's the whole point of doing all this. All right, second one. Second one states we are going to stencil. Guys, we're going to come on. We're going to stencil wooden boxes because your wife saw it on Pinterest and said you need to do this. I'm telling you, that Pinterest thing is crap. Anyway, You are stenciling wooden boxes to sell at a fair. It takes you 2 hours to stencil a small box and 3 hours to stencil a large box. You make a profit of $10 per small box and $20 for the large box. But your passion is stenciling wooden boxes.
Get a job.
Right, yes. This could be, like you should say, it could be third world countries that's what they do, to sell it to tourists. So there's that. Do you feel bad about yourself now? Yes. Anyway, if you have, guys, if you have no more than 30 hours available to stencil and you want to sell at least 12 boxes, how many of these should you stencil to maximize your profit? Again, objective. What's your objective here? Maximize profit. So, again, what we need to do is go through the problem and identify where they talk about profit. Your objective is to maximize profit. How much do you make for profit on a small box? And then large is. So again, we'll use 10 for the small plus 20 for the large. I just realized I just used two problems that kind of started the same way. Now, going into it itself, it talked about hours available and the quantity it wanted to sell. Did I see that? So how many hours do you have available to stencil? 30. Okay. So can you go more than 30 hours? No. Can you include 30 hours? Yes. 30 hours. Now, remember how I think some of you guys were asking me about will we ever see things that are just less than or greater than these? This is kind of the reason why we don't see that very often. Because you can use up to 30 hours. You can include 30 hours, but you're not going to go over. Now, where in the problem does it talk about the amount of hours it takes per unit? The second sentence. Very good. So how many hours do you have for the small? And okay, not too terrible. All right. And then lastly, it says you want to sell at least 12 boxes. Is that the maximum you're going to sell or the minimum you're going to sell? The minimum. Remember, at least. At least. That's the bottom amount you want to sell. Does it say how many, does it say that you're going to sell 3 small for every large or 2 large for every small, or anything like that? So what do I write here? S plus L. Your sales is S plus L. I get it. You don't like it. Stop complaining about it. Write it down and pay attention. That's all I can tell you about it. Complaining about it is going to get you anywhere. Okay? Seriously. This is hard. This is hard. I know. It took a couple of weeks, but it gets there. And it's usually right about now when Serious pops out and says, stop complaining. Get over it. All right? Is this, can you have negative boxes? First quadrant problem. And notice you're back to a problem that you've done, I would say millions of times, but a few times here and there. Yeah, okay. Excuse me. Does it matter what side is what? Nope. Let's flip to the other one because remember how we used, we put S first again here? So let's use that as our X value so we don't have to worry about it. So we'll put small and large. And now we just go through and get our intercepts just like we did earlier. Let's see, we've got the first one, we have S-intercept at 15 and a large intercept at 10. So 15 and 10. Inward or outward? inward. Very good. Remember, it's not going through the origin, so we just say 0 plus 0 is smaller than 30, and we're good to go. So we're pulling inward. Next one, we have intercepts at 12 and 12. A lot of them are. There's not much crazy variation here. But this one goes what direction? Outward. This one goes outward. So now, it's that little triangle on the right, isn't it? You see that? That little triangle spot in the right. So we have to figure out the intersection of those two. Once again, notice my suggestion is just to say that small equals 12 minus the large. I always thought that substitution's a quick method. Go back and solve for the intercept. Twice 12 minus the large plus 3 times the large is 30. 24 minus 2 large plus 3 large is 30. 4 large is 6, which makes small 6. Okay. What 3 ordered pairs do you have to worry about? 6, 6, 12, 0, 15, 0. Okay. I forgot my profit. What was it? 10S, 20L. What are you going to buy? Or what are you going to sell? There you go. Believe it or not, these are probably the types of word problems that make the most sense for really running any type of business, any type of profits, or any type of what you have available in order to produce something. If you're going to build tape recorders, and you only have a certain amount of parts, and you only have a certain amount of time, how many can you build of certain styles and certain types in order to maximize profit out? This is what they do in econ. Seriously, this is just all economics. A lot of this is supply demand, very basic style stuff. Right? Now, the idea here is, can we build these to graph them? The trickiest part for students is to get the constraints. Once you get the constraints down, the graphing portion is easy. I'm not like overstepping the idea that I think by now we're all okay with the graphing part. Yes, no? If not, please, by all means, ask questions. Come into Flex. Come in the morning. We're here in the morning, but just make sure you clear that out. That's kind of what we're getting at here. Can we find the information within all the minutia of a problem? Seriously, and that's kind of what it is. Identify what you're looking to maximize, minimize, what's your goal, what's the end game. Find the information about it. What are the other bits of info they talk about? Time, money, things like that. Not getting over stressed about problems. Not saying right away. It's the idea that yes, you can get it. Then work through it. Let's try some more. going to start with the first one. I'm not going to do all of these for homework. We're only going to do like 3 of them, but I want to I want to start helping you out with a little bit of it. All right. First problem. Thank you. It's just much easier to just throw stacks of papers at people and let them figure it out and go from there. Exactly.
Fly High Airlines sells business class and tourist class seats on its charter flights. Charter a plane at least 5 business class tickets sold and at least 9 tourist class tickets sold. Plane doesn't hold more than 30 passengers. Make a profit of $40 for each business class and $45 for each tourist class. In order for Fly High Airlines to maximize its profits, how many tourist class seats should it sell? So, what's your goal?
Maximize profit. Right? Your goal here is to maximize profit. Now, they talk about 2 types of seats, business and tourists. So, and only one matters, but remember, it's going to be an ordered pair, so that's just, you'll figure out the ordered pair to maximize profit, and you can pick that piece of info out of it. Okay? So, in this case now, if we start looking at it, what 2 letters should I use for my seats, for my sub? D and T. So I have business class plus tourist class. What's my profit on business? And then tourist, 45. So it's 40 and 45. There's your first bit of info. You look to see what your objective is. Well, I want to make money. It's helpful. I want to maximize my profit. Okay? Well, it also said in order to charter the plane, how many tickets of business must you have? So what's the bottom end of business? 5. What is the bottom end of tourists? 9. So your business class has to be greater than or equal to 5. Your tourist class has to be greater than or equal to 9. Now, instead of being it's still first quadrant problem because you can't have 0 seat or less or negative seats. What this is doing is just saying that there is a baseline that you have to sell. Does that make sense? So instead of being at, we're still in first quadrant, but instead of being all the way at B, we're here. We've moved it over a bit. Okay, we've just shifted over. We'll come back to that. All right. How many seats does the plane hold? 30. So, what do you have to have? I mean, ticket-wise, what should it add up to equal 30? E plus T. And it has to be less than or equal to 30. You okay with that? Lastly, can you have negative seats? No. So you do have that idea where you don't really have to, but sometimes it's easy for in your mind. It's sometimes then when you know you're restricted to that space. I'm sorry, this space that you're looking at it. In your mind, if you know that you're restricted to that space, even though you do have that extra parameter, it's not bad. You don't have to. That's the idea. So now we know that we have that first quadrant problem. Business, tourists. If business has to be greater than or equal to 5, here's 5, and it's got to go this way. Tourist has to be greater than or equal to 9. Oops. Okay, so far so good. And what are the intercepts for the other one? 30 and 30. Oops. Not drawn to scale. Not drawn to scale, exactly. Now it's just a matter of getting the intercepts. See how fast it just gets to these intercepts then? intercepts are pretty easy to get now because you've got verticals and horizontals, which means that's at 5 and 9. Oh, which way am I shading with that arrow? Inward or outward? Not arrow, excuse me. That last equation. Inward, good. So I'm looking at this little triangle here. Vertical, that means all those x values, in this case, all those b values are always going to be equal to what? 5. Horizontally, all those y values, or in this case, t values, are all going to equal 9. So if this is at 5, and this is at something 9, what's the value of t when b is 5? Remember, it has to add up to 30. It's got to be 25. Makes the other one 21. See how that works? I think you had a problem very similar to this the other day, where there was one that had that, if I'm not mistaken. Was it? Yeah, I think it was like 18. Very similar to like number 18 when you had the extra vertical. Same thing here with 15. Same basic idea where you have your. Oh, we did? Ah, never mind. 14 was like that too, kind of, where you make the box. Where you make the box. Okay. So you've got your 40b plus 45t. We have ordered pairs at 5 and 9, 21 and 9, 5 and 5. Okay. So at this point, you could probably stop because it gives you multiple choice. Which of those values is a multiple choice answer for the question? 25. Okay. It's still the idea that it gets you going through it, but you have to know how those work. Does that make sense? Okay. I'd like you guys to do the next 3. I want you to try numbers 2, 3, and 4. Number 5's got a typo in it. We'll explain that tomorrow. So on this sheet here, 2, 3, 4. Okay? Yeah. Yes. Oh, the scales. Yeah, that's kind of weirdness because yeah, and the scale. I would do. See how you got your 5 here, and then go over around that, the 9 higher than that. See how you scale 5. Next one. Does that make sense? Okay. Now, real quick, just so you guys, a little hint and a tip here. In number 2, find the maximum profit the company can make if it charges this and this, and then how many students tickets should you sell. Number 3, again, you want to sell airline tickets. A lot of airline tickets here apparently today. You want to maximize profit in number 3. And looky, on number 4, you want to maximize profits again. Okay? So, what's that? Yeah, 5 has a, it should say at, I think it says at least, and it should be at most. Yeah, where it says national short, it should say at most. It's a weird one. I've got more of these. We'll do more of these tomorrow as well. All right? It wasn't terrible, was it? Remember, you're looking for a couple pieces in each problem to identify. All right? Yeah, well.